All right, buckle up, everybody, because today we are diving deep, deep into the world of cardiology,
Oh, yeah.
specifically cardiac output.
Love it.
We've got a fantastic guide for this deep dive, Dr. Eldeeb's Physiology handout,
It's a
and
good one.
it really is jam-packed with info, and we're
Right.
going to break it all down
Absolutely.
so you can walk away from this deep dive
Yeah.
feeling like a cardiology whiz.
Minus the med school.
Yeah, exactly, minus the med school and the student debt.
Exactly.
So I think a good place to start is with a relatable analogy.
Okay, like it.
Cardiac output is kind of like the horsepower of your car engine.
Yeah, perfect. I love that analogy.
It tells you how much power your heart's packing.
Yeah, or maybe like the flow rate of a water pump.
Ooh, that's good too.
Just to kind of give people a sense of, how much blood is actually moving through the system.
Exactly, how much that heart is really working.
Yeah.
So if you've ever wondered what really impacts how much blood your heart pumps each minute, well, today's deep dive is for you.
Absolutely.
Let's unravel the mystery of cardiac output.
Let's do it.
So first things first, what exactly are we talking about when we say cardiac output?
So at its core, cardiac output is simply the volume of blood that each ventricle pumps out every single minute.
Per minute, okay.
And at rest, it's usually around like 5 liters.
5 liters?
Yeah, which, to put it into perspective, is like filling a gallon jug.
Whoa.
Every 60 seconds.
Every minute. That's amazing.
I know, right? It's impressive.
That is a lot of liquid.
Yeah, for an organ the size of your fist,
It's crazy to think about.
yeah, the heart's a real workhorse.
And it never stops.
No, it doesn't get a break.
Which is a good thing.
Yeah, very good thing.
So the handout mentions that cardiac output is calculated by multiplying heart rate and stroke volume.
Yes.
Could you break those down for me?
Sure, so heart rate is probably the one that's more familiar. That's just the number of times your heart beats per minute.
Okay.
The good old thump we all feel.
Yeah, exactly.
And then stroke volume is the amount of blood that's pumped out
Okay.
with each of those beats,
With each beat.
with each thump.
Gotcha.
So they kind of work together like a dynamic duo.
They're a team.
Yeah, to determine just how much blood is circulating
Okay.
throughout your whole body.
So just to clarify, then
Yeah.
if my heart rate goes up, like let's say I'm running,
Right.
does that automatically mean that my cardiac output is higher?
Not necessarily. No, it's not quite that straightforward.
Okay.
You know, think of your heart as a powerful fire hose
Okay.
pumping blood throughout your body.
Okay. I like it.
Now, cardiac output is kind of like measuring
Mhm.
how much water that hose blasts out each minute.
Okay.
So you could crank up the speed of the pump, right?
Yeah.
But if there's not enough water flowing in,
Okay.
you're not going to get a bigger blast,
Makes
right? So there needs to be enough blood
yeah.
returning to the heart
Yeah.
to
Yeah.
really keep that hose pumping strong.
Okay. So it's not just about the speed.
Exactly.
It's about the volume too.
But yeah, it's the whole system.
I'm starting to get the picture.
Good.
Now, there's another term in this handout that I wanted to touch on. Cardiac index.
Oh, yes.
How is that different from cardiac output?
So cardiac index, it basically takes your cardiac output
Okay.
and adjusts it for your body size.
Oh, okay.
It's kind of like comparing, say, a motorcycle engine
Okay.
to a semi-truck engine.
Okay. Yeah.
Both powerful, obviously, but in very different ways.
Right, yeah.
So cardiac index gives us a more accurate picture
Okay.
of how well your heart's actually functioning
Uh-huh.
for your body specifically.
So it's a more personalized measurement.
Exactly. Yeah.
That's really interesting.
Yeah.
So we've talked about how much blood is pumped per minute, but what about each individual heartbeat?
I think that's where stroke volume comes in, right?
You got it. Stroke volume is all about how much blood gets pushed out
Okay.
with each squeeze of your heart.
With each beat?
With each beat, yeah.
Okay.
Think about filling up a water balloon.
Okay.
Okay, so end diastolic volume.
Yeah.
That's how much water is in the balloon before you launch it.
Before the squeeze. Okay.
Exactly. That's the blood in the ventricle before it contracts.
Okay.
And then end systolic volume.
Yeah.
That's that little bit of water left clinging to the balloon
Yeah.
after you've launched it,
Yeah.
It's the blood remaining after the ventricle contracts.
So stroke volume is basically the amount of water that
Ye-
actually gets launched out of the balloon.
You got it.
Okay, that's a great visual. I like that.
Good. Glad you like it.
And then so the handout also talks about ejection fraction.
Oh, yeah.
What is that all about?
Ejection fraction is basically a measure of how efficiently...
Your heart is emptying with each beat.
Okay.
So it's the percentage of blood that's launched out with each squeeze.
With each beat, okay.
Yeah, the healthy heart usually ejects like between 55% and 80%.
Wow.
With each beat.
That's pretty efficient.
It is. It's pretty impressive.
Now, our hearts aren't just, ticking away at the same speed all the time, right?
No, definitely not.
So how do changes in heart rate actually affect cardiac output?
Well, that's where it gets really interesting.
Okay. I'm intrigued.
Because some things that you might think would have a big impact actually don't affect it as much as you'd expect.
Okay, like what?
Like, for example, sleep.
Sleep doesn't affect it.
Not hugely, no.
Interesting.
And also moderate temperature changes.
Really?
Yeah, they don't cause major shifts.
So even if I'm, freezing my butt off...
Yep, pretty much.
Or having a, super intense dream...
Yeah, pretty much.
My cardiac output is staying pretty steady.
Yeah, it's pretty remarkable how stable it is. In those situations...
The body's pretty amazing.
It is. It's really good at maintaining balance.
Okay, but I'm guessing there are some things that DO cause some big swings.
Oh, absolutely.
Okay, maybe not winning a Grammy.
Right.
But what are some real-world examples?
Well, exercise is a big one.
Yeah.
Exercise can crank up your cardiac output.
Really?
By a whopping 700%.
What?
Yeah, it's incredible.
That's huge.
It is huge, and it's because your body needs way more oxygen-rich blood flowing to those working muscles.
Yeah.
But it's not just physical exertion, though. Yeah. Things like excitement or a big meal, even just feeling hot, can all nudge cardiac output up a bit.
So it's not just about exercise. It's like anything that gets the heart pumping?
Yeah, exactly. Anything that increases the demand.
Wow. Okay, so that's a huge GE range.
It is. It's impressive.
What about the opposite? What kind of things would make our cardiac output plummet?
Well, believe it or not, something as simple as standing up quickly.
Oh, really?
Can cause a temporary dip.
Really?
It's all about gravity.
Oh, okay.
And how blood flow adjusts to that sudden shift.
Oh, that's interesting.
And then, of course, certain heart conditions can also lower cardiac output.
Yeah, of course.
As the heart struggles to pump effectively.
Okay, yeah.
So, there's a whole spectrum of things that can influence it.
This is all so fascinating.
It is, isn't it?
Makes you really appreciate just the incredible work our hearts do every second of every day.
Yeah, it's pretty amazing.
But speaking of behind-the-scenes action, how do doctors actually measure cardiac output?
Good question.
It's not like they can just peek inside and see a number, right?
Yeah, no, it's a bit more complicated than that.
Okay, so how do they do it?
There are a few different ways.
Okay.
Each with its own unique approach.
I am all ears. Let's unravel the mystery of these cardiac output measurements.
Okay, so first up, we have echocardiography.
Okay.
Which uses sound waves to create images of the heart.
So it's like a sonogram for the heart.
Exactly. It's very similar. Yeah. And it lets doctors see the heart in action.
Yeah.
And measure how much blood is being pumped.
Okay, so that one's pretty straightforward.
Yeah, it's a direct visualization.
What are some of the other techniques?
Well, there's one called fixed principle.
Fixed principle?
Yeah, it sounds a little intimidating.
A little bit.
But it's actually pretty elegant.
Okay, so how does it work?
So essentially what we do is we measure how much oxygen you're using.
Okay.
And then we compare the oxygen levels in your arteries and veins.
Okay.
And by looking at that difference, we can calculate how much blood your heart must be pumping to deliver that oxygen.
Throughout the body. Okay.
Throughout your body, exactly.
So it's kind of like measuring the oxygen flow.
Yeah, you could think of it that way.
Through your engine to figure out how efficiently it's working.
Yeah, it's a good analogy.
Okay, that's pretty cool.
It is. It's clever.
Are there any methods that give us like a more visual representation of blood flow?
Absolutely, yeah. So imagine like injecting a tiny drop of like bright red dye into your bloodstream.
Okay.
This is called the indicator dilution method.
Okay.
And we can literally watch it flow through your heart.
Wow.
And measure how fast it gets diluted by your blood.
Oh, wow.
And this creates a curve that tells us all sorts of things about your cardiac output.
That's amazing.
It is. It's pretty cool.
So it's like watching a colored stream flow through a pump and figuring out the flow rate based on how quickly the color spreads. That's amazing.
It's a good way to visualize it.
Okay, and then what was that last one?
Oh, the last one is called the thermodilution method.
Thermodilution, okay.
And it's similar to the dye dilution.
Good.
But instead of dye, we use a cool saline solution.
Oh, interesting.
And by measuring the temperature changes
Yeah.
in your blood as the solution mixes in,
Okay.
we can calculate cardiac output.
Okay.
So both techniques rely on this principle of dilution,
Yeah.
using a known quantity of something
Okay.
to figure out the volume of blood it's mixing with.
That's really clever.
It is. It's pretty neat.
This is all so cool.
It is. It's fascinating stuff.
But it does make you wonder,
Yeah.
like, how does our body actually manage
Yeah.
to control this complex process?
Yeah.
It's not like we consciously think, okay, heart, pump a little faster now.
Right. Exactly. It's all happening behind the scenes.
So what is going on behind the scenes?
Well, you might not be consciously controlling it,
Yeah.
but your body's a master conductor of this intricate orchestra.
I like that.
It uses a combination of intrinsic and extrinsic regulation
Okay.
to make sure your cardiac output is always right on point.
Intrinsic and extrinsic. Sounds like we're getting into some serious physiology here.
We are, but don't worry, I'll keep it clear.
Okay, good.
So intrinsic regulation basically means
Yeah.
the heart can control its own output
Okay.
without needing help from, like, nerves or hormones.
So the heart has its own internal control system.
Yeah, it's pretty amazing.
That is amazing.
It is. How does that even work?
So we call this autoregulation,
Okay.
and there's two main types, heterometric and homeometric.
Okay, those are some big words.
They are, but we'll break them down.
Okay.
So heterometric autoregulation is all about preload
Okay.
and the Frank-Starling law.
Frank-Starling law.
And this law states that the more your heart muscle is stretched,
Uh-huh.
the stronger it contracts.
Oh, okay.
Think of it like a rubber band.
Okay.
The more you stretch it, the harder it snaps back.
Okay, yeah, that makes sense.
Right. So as more blood returns to the heart,
Yeah.
the muscle stretches and contracts with more force.
Leading to a bigger pump.
So more blood in equals more blood out.
Exactly. That's the basic idea.
Okay, I'm starting to see how this all works together.
Good.
Now, what about homeometric autoregulation?
So homeometric autoregulation, that's all about afterload.
Afterload, okay.
Think of it as the resistance
Okay.
your heart has to overcome to push blood out
Okay.
into your arteries.
Okay, yeah.
It's kind of like lifting a lightweight versus a heavy one.
Oh, okay.
Your muscles adjust how much force they use,
Yeah,
depending on the resistance they meet.
right.
So similarly, your heart adjusts pumping power,
Okay.
depending on the pressure it needs to work against.
So even if the amount of blood in the heart stays the same,
Exactly.
it can still adjust how hard it pumps,
Yes.
depending on the pressure in the arteries.
Exactly. It's pretty amazing.
That's pretty incredible.
It is. It's a very adaptable organ.
So both heterometric and homeometric are crucial for keeping our cardiac output stable,
Exactly.
especially when we're exercising or if we have a heart condition.
Exactly. It's all about maintaining balance.
So that's the intrinsic regulation.
That's the intrinsic side of things.
But we also have extrinsic regulation, right?
We do, yes. That's the other half of the story.
Okay, so now we're talking about the conductor of the orchestra.
We are.
What kind of factors are we talking about here?
So think things like hormones,
Okay.
nerves, even certain drugs.
Okay.
So, for example, adrenaline,
Adrenaline, yeah.
that rush you feel when you're excited or stressed,
Right?
that can actually increase
Okay.
your heart's contractility,
Okay.
which gives your cardiac output a boost.
So that's why our hearts race.
Exactly.
When we're feeling those strong emotions.
It's your body preparing you for action.
Wow, that's so cool.
It is. It's amazing how everything's connected.
And then there's the I always forget what it's called. The
Autonomic nervous system.
Yes, the autonomic nervous system.
Yes.
Like the fight or flight versus rest and digest.
Exactly, yeah.
How does that play into it?
So the sympathetic nervous system, that's like hitting the gas pedal.
Okay.
It ramps up your heart rate and contractility.
When you need to like run away from something.
Exactly, when you need a burst of energy.
Yeah.
And then the parasympathetic nervous system acts like the brakes,
Okay.
slowing things down when it's time to relax.
So it's all about adapting
It is.
to different situations.
Exactly.
Making sure our heart is pumping at just the right pace for what our body needs at that moment.
Exactly. It's a beautiful system.
Yeah, I'm starting to see just how intricate this whole system is.
It is. It's incredibly complex.
Wow. And we can't forget about medications, right?
Oh, yeah. Medications play a role, too.
How do those affect cardiac output?
So some drugs, like digitalis, can actually increase the force
Okay.
of your heart's contractions. while others, like xanthines,
Yeah.
can affect how your heart responds to certain signals.
So it's a delicate balancing act.
It is. It really is.
With so many factors working together
Yeah.
to keep your heart pumping efficiently.
Yeah, it's remarkable.
We've covered a lot of ground here.
We have.
From the basics of cardiac output
Yeah.
to the intricate mechanisms that control it.
It's a fascinating topic.
It really is, and I feel like we've only just scratched the surface.
We have. There's so much more to explore.
I'm excited to dive even deeper.
Me too.
After a quick break, we'll be back to explore even more fascinating aspects of this incredible system.
Can't wait.
Welcome back to our deep dive on cardiac output. Now, before the break, we were talking about all the factors that influence how our heart pumps.
Right. All those intricate mechanisms.
And I have to admit, I always thought
Yeah.
a faster heartbeat automatically meant more blood was being pumped.
Uh-huh.
Is that always the case?
Well, that's a common misconception. But it's not always that simple.
Okay.
You see, if your heart is beating super fast,
Yeah.
there might not be enough time for the ventricles to fill up completely
Oh.
between beats.
Oh, okay.
So that means less blood gets ejected with each contraction.
Even though the heart is working harder.
Exactly. Even though it's beating faster.
So it's like trying to fill a bucket from a faucet.
Yeah.
Yeah, I like that analogy.
If you turn the faucet on and off really quickly,
Right.
you're not actually going to get as much water in the bucket
Exactly.
as if you let it flow steadily for a bit.
A perfect analogy.
Okay, so this is especially relevant then
Mm-hmm.
in cases of like certain fast heart rhythms,
Right.
where venous return, that's the blood flowing back to the heart,
Yes.
remains constant.
Right.
So the heart rate might be through the roof,
Yeah.
but the actual amount of blood being pumped
Can actually decrease.
can decrease.
Because those ventricles aren't getting a chance to fully refill.
Oh, that's interesting. Yeah, it's counterintuitive, but that's how it works.
So there's a sweet spot for heart rate then.
Yeah, you could say that.
Too slow and we're not getting enough blood out.
Right.
Too fast and the heart's not filling properly.
Exactly. It's all about finding that balance.
What about when our body actually needs more blood pumping?
Mm-hmm.
Like during exercise?
Oh, yeah, that's when things get even more fascinating.
Okay, lay it on me.
So when we exercise, our muscles demand more oxygen.
Okay, makes sense.
And that means our venous return increases.
More blood coming back to the heart.
Exactly. And the heart responds by doing a sort of double whammy.
Okay.
Not only does the heart rate increase,
Okay, beats faster.
but the stroke volume also goes up.
So our heart is not only beating faster, it's also squeezing out more blood with each beat.
Exactly. It's like a super pump.
And that's how our body keeps those muscles fueled and oxygenated when we're pushing ourselves.
Exactly. It's an incredible adaptation.
It really is.
That ensures our muscles get the resources they need.
It's amazing how our bodies just know how to do that.
It is. It's really quite remarkable.
So we've got this super efficient pump working away,
Uh-huh.
sending out all this oxygen-rich blood.
Yes.
But where does it all go?
Right.
Is it distributed evenly throughout the body?
Not at all. Different organs have different needs.
Oh, okay.
So blood flow is constantly being adjusted
Okay.
to make sure everything is getting what it needs.
So it's like a delivery system,
Yeah, you could think of it that way.
prioritizing certain areas depending on demand.
Exactly. It's all about efficiency.
So which organs are getting the VIP treatment?
Well, the real MVP in terms of blood flow at rest
Okay.
is surprisingly the liver.
The liver, really?
It gets a whopping 25% of cardiac output.
Wow, that seems like a lot.
It is. It's a busy organ.
But why would it need so much blood?
Well, the liver is kind of like the body's detox center.
Oh, okay.
It filters out all sorts of toxins from our blood.
Okay, so it's like a filter.
Exactly. It also plays a crucial role in digestion,
Okay.
producing bile that helps to break down fats.
I didn't know the liver did that.
It does. And let's not forget its role in metabolism
Right.
and immune function.
So it's doing a lot.
It really is. It's a multitasking champion.
So all those processes require a constant supply of blood
Exactly.
to keep things running smoothly.
To keep the liver happy and healthy.
Okay, so the liver is taking the lion's share. Where does the rest of the blood go?
So the kidneys come in second place,
Okay.
snagging about 22% of cardiac output
To be what?
to filter waste products from the blood
Okay.
and regulate fluid balance.
Okay.
And then, of course, our muscles,
Even at rest.
even at rest, yeah.
You get about 20%.
About 20%, yeah, to keep them fueled and ready for action.
Wow. It's like a complex traffic control system.
It is. It's very intricate.
Directing blood flow where it's needed most.
Exactly. And it's happening all the time without us even realizing it.
This all makes me wonder, are there things we can do to optimize our own cardiac output?
Yeah, great question.
Or is it mostly out of our control?
That's a great question, and it's one we should all be asking.
Okay.
You know, while our bodies do an amazing job of regulating cardiac output automatically,
Yeah.
there are definitely things we can do to support this vital system and keep our hearts healthy.
So we're not just passive passengers in all of this.
No, not at all.
We actually have some agency when it comes to our heart health.
Absolutely. We have more control than we might realize.
Okay. I like that. I like that a lot.
Yeah.
So remind me again those extrinsic factors we discussed earlier.
Right. So those were hormones, nerves, even certain drugs. Right.
Well, many of these can actually be influenced by lifestyle choices.
Exactly. That's the key.
Okay, so like what kind of lifestyle choices are we talking about?
Well, for example, one of the most powerful things you can do for your heart is regular exercise.
So hitting the gym isn't just about building muscles.
Right.
It's like giving our heart a workout too.
Exactly. It strengthens your heart muscle.
Okay.
Improves its efficiency, helps boost stroke volume.
So it's like training your heart
Yeah.
to be a lean, mean pumping machine.
Exactly. That's a great way to put it.
So it's like training our heart to be a lean, mean pumping machine.
Exactly. That's a great way to put it. And don't underestimate the power of stress management.
Oh, right, stress.
Yeah, chronic stress can really wreak havoc on your cardiovascular system.
Stress can literally break your heart.
Well, it can contribute to high blood pressure and other issues,
Okay.
which can strain the heart and impact cardiac output.
So it's not just about, like, emotional stress.
No, it's about the physiological effects of stress.
Okay, so finding healthy ways to manage stress.
Yes.
Whether it's through exercise, meditation, or spending time in nature.
All great options.
Can make a world of difference.
Absolutely.
It's all about taking care of our hearts,
Yeah.
both physically and mentally.
I love that.
Makes sense. What about our diet?
Oh, diet's huge.
Does that play a role in cardiac output too?
Absolutely.
Yeah.
You wouldn't put low-quality fuel in a high-performance engine, right?
Right.
Your heart deserves premium fuel, too.
So what should we be eating?
A diet rich in fruits, vegetables, and whole grains.
Okay, the usual suspects.
Pretty much. But it can do wonders for maintaining healthy blood pressure
Okay.
and cholesterol levels, which are essential for optimal heart function.
So what we eat directly impacts our heart's ability to pump efficiently.
It all comes back to that.
I'm starting to see a theme here. Taking care of our overall health is the key to a healthy heart.
You got it. It's all connected.
Everything's connected?
When we make healthy choices, we're not just benefiting one organ.
Right.
We're supporting the whole system.
I love that. This has been an incredibly illuminating deep dive into the world of cardiac output.
It has been a fascinating journey.
I feel like I've unlocked a whole new level of understanding about how my heart works.
Now remember, this is just the tip of the iceberg.
There's always more to learn.
Absolutely. There's always more to discover about this amazing organ and how it keeps us going.
Huge thanks to Dr. Eldeeb for providing such a fantastic guide for this deep dive.
It's a great resource.
It really is. We've covered so much today.
We have.
From the basics of cardiac output and the factors that influence it,
Right.
to the incredible ways our body regulates this vital process.
A truly remarkable system.
It's been quite a journey.
It has.
And we've even explored how cardiac output is measured.
Yes.
And that surprising fact that increasing heart rate doesn't always mean increased blood flow.
Counterintuitive, but true.
But perhaps the most important takeaway is that we have more control over our heart health than we might realize.
Absolutely.
By making conscious choices about exercise, stress management, and diet,
Right.
we can directly impact our heart's ability to function at its best.
Couldn't have said it better myself.
So as we wrap up this deep dive,
Yeah.
remember to listen to your heart,
Yes.
both literally and figuratively. I love that.
Take care of it, and it will take care of you.
Words to live by.
Until next time, deep divers.